Hello, this is Naz from NB Network Lessons. Hope you guys are doing okay. My today's topic of discussion is Algebra Lesson 22, and we're going to talk about imaginary numbers. Now, what the heck are imaginary numbers? So, let me try to see if you can visualize something. So, real numbers like 2, 3, 4, 50, 100, you can hold them in your hand, right? Similarly, negative numbers, which are also real numbers, for example, negative 10, negative 20, negative 50, if you have a negative balance, negative $50 balance in your account, that means you owe the bank $50. So you can relate with these numbers, right? But with imaginary numbers, you cannot really relate like just by looking at them because they are odd, they are unique. However, just to give you a motivation, if you're planning to become a scientist, if you're planning to become a mathematician, if you're planning to become an electrical, mechanical, civil engineer, you will have to use imaginary numbers in real life. If you're designing a grid station to deliver power, you will need imaginary numbers. You will mix them up and come up with a real number. Same thing if you're in construction and you are building a bridge and you need to calculate suspension, how much weight it can bear, or you're building a high-rise building and you want to make sure that it's stable. Complex number, not complex, but imaginary numbers are going to play a role in that. You will have to mix them up and come up with a real number. So without any further ado, let's dive into imaginary numbers and see what the heck they are. So, there is a radical, like for example, under root of 9. I can get answer to that is 3, which is a real number, which is fine. Under root of 4 is 2, which is a real number, which is fine. I can relate to that. But what if I have something like this? Under root of minus 1. Now that's odd. You can't take square root of negative 1. So, but there is a use of that in real life. So what you do is that scientists and mathematicians have come up with a name and they call this I, which is equal to, which stands for imaginary number. Okay? So let that sink in for a second. So if I do I square, I will get minus 1. Would you not agree? I'm taking square root of both sides. When I take square, I get rid of the square root sign. So let's look at an example. I think it'll make more sense if I solve some problems, then you can probably see it clearly. So let's say we have x squared equal to minus 1. All right, I want to isolate for x. So I can take square root of both sides. If I do, I get x on the left hand side, and then this will become plus minus under root of minus 1. Now I know that we've already established that negative under root 1 is I. So I can say the answer is x is equal to plus minus I. All right, easy peasy. So let's look at another problem. Let's say you have x squared is equal to negative 4. Same thing, you take square root of both sides, isolate x, and then you get minus 4 under root, and you have plus and minus. All right, now what we need to do is we already know that I is equal to negative 1 under root. So what I can do is, then I can write this as x is equal to plus minus 2i. So that would be my answer, right? So think about that for a second. How did I come up with this 2i? All right, so basically if I have something like this, minus 4, okay, I can write this as 4. I square is minus 1, I can write this as 4I square. Would you agree? Because if I multiply 4 by I square, I still get negative 4, right? So then, there's a plus minus sign. Then if I pull this out of the square root, all right, then I get 2I, plus and minus. So that is my final answer. All right, so let that sink in. Watch this video maybe a couple of times and it'll make sense to you. I'll come back and do one more example and then we'll go from there. But thank you so much for watching. If you like the video, please share it and also go ahead and give me a like. Thanks a bunch.